Good evening, students. Today we are going to discuss the new topic of linear differential equation. There are two types of linear differential equation, that is linear differential of constant coefficients and the homogeneous equations with the variable coefficients. Today we will discuss only the differential equations which have constant coefficients. Constant coefficients, first of all we will define it. Let's suppose there is a differential equation like this one in the form of dn of y xn and a1 a2, where a1 a2 an are the constants. That is why we call it as a linear differential equations with constant coefficients, and qx is the function of x. If we call it write as d by dx as d and set in derivative as d square and nth derivative so on, nth derivative will be dn, then the equation will become as dny plus a1 dn minus 1 of y and so on, an of y is equals to qx. Or we can say it is a function of d of y having a coefficient of constants is the qx. Now we will discuss how to solve it. For solving this type of the linear differential equation, we have to find two types of solution. First of all, complementary functions. In that case, this qx will become 0. When qx will become 0, we can say it is a constant coefficient equation. We have to find the complementary function. If there is a function of qx there, then we will find complementary function as well as particular integral. Let us discuss about this. So here we go further ahead. For the solution of f dy of qx, in case when qx equals to 0, the equation will become like this one. Then the step number 1 is obtain auxiliary equation by replacing d as m in f.d. we get the equation can be written as with an m to the power n plus a1 m n minus 1 plus a2 m n minus 2 and so on, plus an is equals to 0. Let's suppose, because it is an polynomial equation, so we can say it have nth root also. So we can say let the n roots of the equation are m1, m2 and so on, mn. Now there are few steps we have to remember that. Case number 1, if all roots are real and distinct, then the complementary function, the solution, you can say the solution is y is equals to c1 e to the power m1x plus c2 e to the power m2x plus and so on plus cn e to the power mnx. This is our solution if the all roots are real and distinct. Now ahead for that, if there are some other cases also. Case number 2, if we can say if m1 is equals to m2, say m, then the solution is y is equals to e to the power mx, you can say c1 plus c2x e to the power mx plus c3 e to the power m3x and so on. Means when there are two equal roots, then we can write as c1 plus c2x, and the equal root will become only one time. Case number 3, if m1 is equals to m2 is equals to m3, say m, now there are three equal roots, then y will equals to c1 plus c2x plus c3x square of e to the power mx plus c4 e to the power m4x and so on. There are some special cases also. Means there is no necessity that always a simple roots are there. There can be also the complex roots. So case number 4, if m1 is equals to a plus iota b and m2 is equals to a minus iota b, so we can say about complex roots. Then what about y? Then y is equals to e to the power ax c1 cos bx plus c2 sin bx plus c3 e to the power m3x and so on. If there are only one complex root is there. Case number 5 also there. If roots are equal and imaginary, I mean to say the roots are a plus minus iota b, again there are another root a plus minus iota b, then what will happen? Then we have to combine the two rules, case number 4 and case number 2 also. We will combine both the methods. Then I will get y is equals to e to the power ax, then c1 plus c2x cos bx plus c3 plus c4x sin bx. There is another case, last case we can say, it is a rare one when permitted. Now let the roots are real, different and surds. If roots are real, different and in the surds, what do you mean by surds? Means a plus root b and a minus root b. Now it is not no iota, there is no imaginary root, but in the root, square root form, then the solution will be y is equals to e to the power ax c1 e to the power root bx plus c2 e to the power root minus root bx. This is a special case. You should learn it about this. These 6 type of cases we have to remember for solving the linear differential equations with constant coefficient for solving them. Now let us do some examples so that we can understand it very carefully now. So now is the first example. Solve the differential equation. Here we can say let d by dx is equals to d and d square by dx is equals to d square and so on. Then equation become d cube plus 2d square minus 15d of y is equals to 0. Now for the auxiliary equation, put d is equals to m so that equation become m cube plus 2m square minus 15m is equals to 0. Or I can say m is common, that is m square plus 2m minus 15 is equals to 0. You know how to factorize it. So the factor will be, what will be the factor? That is m plus 1, m minus 3 will equals to 0. So we can say m is equals to 0, m is equals to minus 5 and m is equals to 3. As we get all the solution, we can see here the roots are real and distinct. So the first case, y will equals to c1 e to the power 0x plus c2 e to the power minus 5x plus c3 e to the power 3x. Or we know that as e to the power 0 is always equals to 1, so we can say y will equals to c1 plus c2 e to the power minus 5x plus c3 e to the power 3x. This is a required solution of the given differential equation. Now another question I have written already in short form, d square plus d plus 1 of y is equals to 0. So we can say the solution, the auxiliary equation by putting d is equals to m, we get m square plus m plus 1 is equals to 0. As we know, it is a quadratic equation. So we can use the Sridharacharya rule, or you can say quadratic formula. By the quadratic formula we can say m will equals to minus b plus minus under root b square minus 4ac upon 2a. If you don't remember it, then I write here. So we'll put m is equals to minus b, means minus 1 plus minus 1 minus 4 upon 2a, 2 into a and 1, that is m is equals to minus 1 plus minus, this will be minus 3, which is an imaginary part, so we can say it is iota root 3 upon 2. So we have the two roots, that is minus 1 by 2 plus iota root 3 by 2 and minus 1 by 2 minus iota root 3 by 2. As you can see here, the both roots are complex, so we can say the roots are complex. Then the solution is c1 e to the power ax, means a plus minus iota b form. So it is e to the power ax plus into c1 cross bx plus c2 sine bx. What is a and b here? We can see the real part of the complex root is the a as in the form, and the imaginary part is as b. Put the values, we will get y is equals to e to the power minus 1 by 2 c1 cos root 3 by 2h plus c2 sine root 3 by 2h is the required solution of the given differential equation. Here is another question. Solve the equation d to the power 4 minus a to the power 4 of y is equals to 0. This equation can be written as this one also. So now the auxiliary equation is, by putting d is equals to m, I can say m to the power 4 minus a to the power 4 is equals to 0. Factorizing m square minus a square, m square plus a square is equals to 0, or we can say m square is equals to a square and m square is equals to minus a square. From here I will get m is equals to plus minus a, and here m is equals to plus minus iota a. So there are four roots, that is a minus a and the plus minus iota a. As you can see here, the first two roots are real and different, but the third root is a complex pair root. So we can say the solution y is equals to c1 e to the power ax plus c2 e to the power minus ax for the real and different roots plus e to the power 0x, it is nothing, just 0 plus minus iota a, so it is 0x c3 cos ax plus c4 sine ax. As we know that e to the power 0 is equals to 1, so y will equals to c1 e to the power ax plus c2 e to the power minus ax plus c3 cos of ax plus c4 sine of ax. This is the required solution of the given differential equation. Now for finding the particular integral, we have to evaluate 1 upon fd of qx. This qx can be 5 different ways. The case number 1 is when function qx is in the form of e to the power ax, then particular integral will be 1 upon f of d e to the power ax will equals to 1 upon f of a e to the power ax. Means just put the coefficient of x in the function in place of d. But there is a case when f of a should not be equals to 0. This is the important part. This f(h) can never be equals to 0. If f of a is equals to 0, then there is a important formula for finding that. You should always learn this formula is 1 upon d minus a to the power r of e to the power ax will always equals to x to the power r upon r factorial e to the power ax. This is a very useful formula. You should remember it always. This will be applied when f of a is equals to 0. Then we will use it in different way. Let us do some example first of all for this, then we will go ahead. So here is the first example for finding the particular integral as well as solve the differential equation. As we know, for solving this differential equation, there is a function of x. So we will have to find the complementary function as well as particular integral. So first of all, for complementary function, the auxiliary equation is m square minus 3m plus 2 is equals to 0. So that I can say m minus 2, m minus 1 is equals to 0. So m is equals to 2 and 1. Therefore, the complementary function CF is y is equals to e to the c1 e to the power 2x plus c2 e to the power x. Now for the PI, means particular function, we have 1 upon d square minus 3d plus 2 e to the power 3x. By applying this formula, we just replace d as a, means coefficient of x, this is 3. So I can say it will become 3 square minus 3 into 3 plus of 2 e to the power ax. It is 1 by 2 e to the power 3x, sorry. This is our particular integral. Therefore, the solution of equation is y is equals to cf plus pi. It means y is equals to c1 e to the power 2x plus c2 e to the power x plus 1 by 2 e to the power 3x. This is our required solution for the given equation. Now there is another question. It is a very important question. Be careful by doing this. First of all, for auxiliary equation is 4m square minus 1 is equals to 0, or I can say m square is equals to 1 by 4, or m is equals to 1 by 2 and minus 1 by 2. So the complementary function y will equals to c1 e to the power x by 2 plus c2 e to the power minus x by 2. This is very easier way. Now see carefully the particular integral. In the case of particular equation, the equation will become 1 upon 4d square minus 1 e to the power x by 2. When I applied the coefficient of x in the d, I will get 0. Here f of a is equals to 0, means I can't apply directly the value of d as 1 by 2. So I will factorize it. For this I will get, it will become 1 by 4 d square minus 1 by 4 e to the power x by 2, or it will be 1 by 4, this is 1 upon d minus 1 by 2 d plus 1 by 2 e to the power x by 2. I just factorized it by a square minus b square. Now if I applied 1 by 2 here, it will become 0. So I will not apply here. First of all I applied here only. Then I will get 1 by 4 1 upon d minus 1 by 2 into 1 by 2 plus 1 by 2 e to the power x by 2. It will become 1. Now the equation just reduce as 1 upon d minus 1 by 2 e to the power x by 2. Now as I write in the previous the important formula, that is 1 upon d minus a to the power r is equals to x to the power r upon r factorial e to the power ax. Apply this rule here. So I will get, it will be 1 by 4 x to the power r. R means the power of this is 1. So it is x upon 1 factorial e to the power x by 2, or I can say it is nothing, just x by 4 e to the power x by 2. Therefore, the complete solution of given equation is y is equals to cf plus pi, or I can say y is equals to c1 e to the power x by 2 plus c2 e to the power minus x by 2 plus the particular integral, that is x by 4 e to the power x by 2. This is our required solution of the given differential equation. Now there is a case number 2. If the qx is the function of sine or cos, then what will happen? Then the solution, the particular integral for the equation is 1 upon of f of d square. I have here, be careful about that, that is d square of sine ax or cos ax, whatever it is, it will equals to 1 upon f of minus a square, whatever it is, sine ax or cos ax. Remember this one. I don't write this square as out of the bracket. It is just on a, not minus. This minus sign will always there when we put sine ax or cos ax. Just we will do an example. We will find the solution. Let us do a simple example. For doing the example, I would like to write some basic formulas. We have already learnt about them. That is, we know that, here I wrote useful formula. We know that sine ax is always equals to e to the power a iota x minus e to the power minus a iota x upon 2 iota, 2a iota I think, yeah. And the cos ax is e to the power a iota x plus e to the power minus a iota x upon 2. These two formulas are very useful in these questions when qx is the sign of cos or function. Let us see how we can solve it. Just take an example. Now there is an example for the case number 2. Equation, first of all we will find the auxiliary equation. So that the auxiliary equation is m square minus m minus 2 is equals to 0. By factorizing, I will get m minus 2, m plus 1 is equals to 0. I can say m is equals to 2 and minus 1. Therefore, the complementary function is y is equals to c1 e to the power 2x plus c2 e to the power minus x. Now, for the particular integral, the function will become 1 upon f of d sine of 2x, or it is 1 upon d square minus d minus 2 sine of 2x. As I told you, the formula for that is 1 upon d square of sine ax is equals to 1 upon f of minus a square sine of ax. Means wherever there is a d square, means even power of d, put the value of coefficient of x in that with the negative sign. So I can say it can be written as 1 upon minus 2 square minus d minus 2 sine of a 2x. Here I can see here a is 2, so I put in d square only, minus sign with outside. So it will become 1 upon minus d minus 6 sine of 2h. Now just minus take it out, and that is 1 upon d plus 6. Just rationalize it. D minus 6 of sine 2h, that is become 1 upon, that is d minus 6 upon d square minus 36. The minus sign is out already. It is sine 2h. Apply again for d square minus 2. I will get minus d minus 6 upon, that is minus 4 minus 36 sine of 2h. It will become 1 upon 40 d minus 6 sine 2h. Now d for derivative, d by dh. So when we multiply this one, I will get 1 upon 40 derivative of sine 2h minus 6 sine 2h. It will become 1 upon 40 derivative of sine 2h will be 2 cos 2h minus 6 sine 2h. So you know how to write. Now the solution is, therefore the particular is this, so we can say therefore solution of equation is y is equals to CF plus PI. This is our PI and this is our CF. Just put these two values and add them, you will get the answer. Now see this question. It is another very important question for the exam point of view. First of all, auxiliary equation, that is m square minus 4 is equals to 0, or I can say m is equals to plus minus 2. So the complementary function y is equals to e to the power c1 e to the power 2h plus c2 e to the power minus 2h. This is the simplest part of this solution. Now this is here for pi, here we can say qx is equals to cross square x. I have the formula for cross ax, not cross square ax. So I will have to change it by taking as it is nothing, just 1 plus cos 2x by 2. You know cos square x is equals to 1 plus cos x 2x by 2. So the pi will be 1 upon d square minus 4 1 plus cos x by 2. As 1 by 2 we are taken out, so it is 1 upon d square minus 4 of 1 plus 1 upon d square minus 4 of cos x. I can write as 1 upon 2 1 upon d square minus 4 e to the power 0x. We know that 1 can be written as e to the power x. Again plus 1 upon d square minus 4 of cos x. Now by the exponential rule, case number 1, when you apply d is equals to 0, it will become 1 upon 2 minus 1 by 4 only, and here it will become 1 upon minus 1 square minus 4 cos x. So it is nothing, just minus 1 by 8 minus, that will be 5 to the 10. This is cos 2x, sorry for that. if there is 2h, then it will become minus 2 square. It will become minus 6, minus 8, minus 8 into 2 plus a minus 1 by 16 cos of 2h. I just write as an h, sorry for that, that is cos 2h. This is our pi. So the complete solution y is equals to cf plus pi, or I can say y is equals to c1 e to the power 2h plus c2 e to the power minus 2h plus, here I can write minus 1 by 8 outside, so minus 1 by 8 1 plus 1 by 2 cos 2h is the required solution of the given differential equation. Now the case number 3, for the equation f dx of qx, when qx is equals to x to the power n, we have to remember the 3 formulas which are very important for this. That is, first of all is 1 upon 1 plus x to the power n. By the binomial extension, you know that it will be 1 plus nx plus n minus 1 upon 2 factorial of x square and so on. But in the particular case, when n is equals to minus 1, then it will be 1 plus x to the power minus 1, which will become 1 minus, when I put n as minus 1, it will become minus x plus, when I put n is equals to minus 1 here, I will get only x square, then minus x cube and so on. In the case when n is equals to minus 1 and x is equals to also minus x, then it is 1 minus x to the power minus 1. Then in this case, when x becomes minus x, these minus sign always get into the positive one, and that is 1 plus x square, x plus x square plus x cube and so on. These are very important for solving this case number 3. Now let us do some examples. You will understand how these 3 formulas are important. Now see this example, this very simple example I have taken first. Now the auxiliary equation is m square minus 13m plus 12 is equals to 0, or I can say m minus 1 m minus 12 is equals to 0. So m is equals to 1 and 12. So the complementary function is y is equals to c1 e to the power x plus c2 e to the power 12x. This is a simple way. Now in the case of particular integral, the function will become 1 upon d square minus 13d plus 12 of x. Remember, I have to make it, convert it in the form of 1 plus x form or 1 minus x form. So for this I will take 12 as a common, so it will become 1 upon 12 such that 1 plus d square minus 13d upon 12 of x. By doing this, I have an easy way to solve it now. 1 by 12 as it is, put this one as upper and it will become 1 plus d square minus 13d upon 12 to the power minus 1 of x. As I told you, the formula 1 plus x to the power minus 1, it will become 1 upon 12 by expanding it by this formula. First of all, you just take the term x. There is x. if y is equals to x, then the first derivative will be 1 and the second derivative will become 0. I have to just go till second derivative, not more than this. So when I expand it, it will become 1 plus d square minus 13d upon 12. Here is the second derivative and first derivative which we have used. Again, the second expansion will be, that is 1 minus, then plus d square minus 13d square upon 12 of, and so on. As I can see here, when I expand it, there is a minimum power of d square we will get, and the d square will become 0. So it means this, for this particular part, the derivative will always 0. So why will we use it? I just take this term only. It will become 1 by 12 1 minus d square minus 13d upon 12 of x. Now just multiply. I will get 1 by 12. This will become x minus second derivative of x, d square of x minus 13 d of x upon 12. You see here, second derivative of x will be 0. So the equation will become 1 by 12 x minus, this will become 0. First derivative will be 1, means 13x upon 12. So the PI is x by 12 minus minus plus, that is will be 1, sorry, minus minus plus, that is 13 upon 144. So the solution is y is equals to CF plus PI. Just add these both solution, you will get the answer. Now this is the example in which the first case, second case and the case number third, all the three cases I have taken. So now solve it. Substitute auxiliary equation, m square plus 4 is equals to 0, means m is equals to plus minus iota 2. So the complementary function will be y is equals to c1 cos 2x plus c2 sin 2x. Now for the pi, it will be 1 upon d square plus 4 sin 3x plus e to the power x plus x square, or it will be 1 upon d square plus 4 sin 3x plus 1 upon d square plus 4 e to the power x plus 1 upon d square plus 4 x square. For this one I have taken a as 3, it will become minus 3 square plus 4 sin 3x. Here coefficient of x is 1, put here, that will 1 square plus 4 e to the power x. But in this case I have taken 4 as out, it will become 1 upon 1 plus d square by 4. I just write it again, d square by 4 of x square. Now for doing ahead, it will become minus 9 plus 4 means minus 1 by 5 sin 3x. It will become 1 plus 1, 4, 5 is 1 by 5 e to the power x, and in this case it is become 1 by 4 1 plus d square by 4 to the power minus 1 x square. For doing furtherly, first of all we take the x square as d, y is equals to x square, and the first derivative is 2x, second derivative will be 2, and the third derivative will become 0. So I just need to go till the third derivative, not more than that. So I will expand this as 1 by 5 sine 3x plus 1 by 5 e to the power x plus 1 by 4. It will be 1 minus d square by 4 plus d to the power 4 upon 16 and so on. Neglect करेंगे, that is x square. I don't need d4 also, but I just write it for you and nothing for this. Now just do the further. 1 by 5 sine 3x plus 1 by 5 e to the power x plus 1 by 4. This x square multiplied by 1, it will become x square minus second derivative of x square. Second derivative of x square is 2. It will become 2 by 4. Therefore, the pi is nothing, simple it is. This is 1 minus 1 by 5 sine 3x plus 1 by 5 e to the power x plus 1 by 4 x square minus 1 by 2. Therefore, the complete solution y is equals to CF plus pi, or it will be C1 cos 2x plus C2 sin 2x plus minus 1 by 5 sin 3x plus 1 by 5 e to the power x plus 1 by 4 x square minus 1 by 2. This is the required solution of the given equation. Now this is the case number 4. If there is a multiple of two functions in which one function is exponential and other is any function of x, either a polynomial or a trigonometric, means in a form of sin x or x to the power n, but the one function as a exponential e to the power ax, then we will take one exponential function at this side by taking the coefficient of x of exponential to the function as a plus a. See here how to solve it. First of all, the auxiliary equation is m square minus 2m plus 4 is equals to 0, or it is nothing, just by solving I will get the solution of this will be as m is equals to, by taking the quadratic formula I can say it is 1 plus minus under root 2 or 3 iota. So the complementary function will be y is equals to e to the power x c1 cos root 3x plus c2 sin root 3x. This is a complementary function. You know how to find it. I am just not taking the time on this. Just we have go to the particular integral now. It is 1 upon d square minus 2d plus 4 e to the power ax. Here ax लेने की बजाय हम ओनली x लें या कुछ और x ही ले लेते हैं, चलो अभी. Then it will be e to the power x cross x. Here the coefficient is 1, so I just use it in here. I can say it will become e to the power x. I just stated it on the left side, and now give the coefficient 1 to the d's, that is d plus 1 whole square minus 2 d plus 1 plus of 4 e to the power x is already there, then it is become cross x only. Now this equation will become as 1 upon, this will be e to the power x into 1 upon, this will be d square plus 2d plus 1 minus 2d minus 2 plus 4 of cross x, or it will be e to the power x 1 upon d square, और जब सीधा 2d से 2d cancel out, that is 4 plus 1 plus 3 of cross x. Now you know how to solve the trigonometric form of this. Here the coefficient of x is 1, so it is e to the power x 1 upon minus 1 square plus 3 cross x, or it will be e to the power x cross x upon 2. So therefore solution is y is equals to e to the power x c1 cross root 3x plus c2 sine root 3x plus e to the power x cos x by 2. I hope you understand how to solve. I just take a simple example. Now just take another example now. Now this is the question. I have to solve it. I am just going to the solving a particular integral. You know how to find the complementary function CF. I just going for the PI now. That is 1 upon d square minus 2d plus 1 x square 3x. Here exponential function with an algebraic. So take the 3x on the left side and just put the value d plus 3 whole square minus 2 d plus 3 plus 1 of x square. I hope you understand how. Now it will become e to the power 3x 1 upon d square. Here will be 6d. There will be minus 2d means plus 4d. Here will be 9 minus 6 means plus 3 plus 1 means 4 of x square. Now because there is an algebraic form, so I have to do here just taking 4 as in common. In this term, this is 1 plus d square plus 4d upon 4 x to the power 2, or it is e to the power 3x by 4. It will become 1 plus d square plus 4d by 4 to the power minus 1 of x. Now again, for doing further, it is x square. I have x square, then the first derivative will be 2x, second derivative will be 2, and the third derivative will become 0. So I have to do maximally third derivative, जहाँ तक आएगा वहाँ लेंगे. तो इसे expand करें तो it is e to the power 3x by 4. It will be 1 minus d square plus 4d by 4 plus d square plus 4d whole square upon 16 of x square. I will just use that power which will be used in our first, second and third derivative till then. That is 1 minus d square plus 4d by 4 as it is. Here I will don't use the power 4 because it will become 0. Power 3, it will also become 0. So there is only one term which have given the power 2, that is 4d square. This is 16 d square by 16 of x square, and all the power can be neglected. Here 16 cancel out. Now just multiply it. It will be e to the power 3x by 4 x square. Second derivative of x square is 2, so it will become minus 2 plus first derivative is 2x, 4 into 2x upon 4 plus here is the second derivative of x square is 2. So it is e to the power 3x by 4 x square, that will be 8x plus 2 upon 4. If I take the 2 as a common, or furtherly you can do it, I can just write it as 2 plus 8x upon 4 plus 2. Clear? Now just use it as a modification rule. So we can say it is e to the power 3x by 4 x square as it is, minus 8x by 4 means minus 2x, that is minus 1 by 2 plus 2 means plus 3 by 2 is the required PI. I hope you understand. Now the case number 4, how to solve it. Now let us go for the next. Now there is the last and the final case 5 of the function, where a function is of x and the other function is anything else, is a sine function or exponential function. Particularly there always a trigonometric function, sine or cos. Just as I take an example, d square plus 4 of y is equals to x sine x. There is a multiple of x with the trigonometric function. So when there is a multiple of x, then we will apply this formula. So I am going to straightforward to the PI. It is d square 1 upon d square plus 4 of x sine x. Again, by using this formula, I can say it can become as x minus derivative of fd. fd is this one. The derivative of this will be 2d minus plus 0, whatever it is, upon f of d as it is, d square plus 4 as it is, into 1 upon f of d of v. v is sin x and f of d is d square plus 4 of sin x. Now for the first we solve this one part, take it as it is 2d d square plus 4 as it is. First solve it by putting coefficient of x is 1. By putting here I will get 1 by 3 sin x. Now 1 by 3 as an out. The other part is x minus 2d upon d square plus 4 of sin x. Again it will become 1 by 3 x minus 2d upon, put the coefficient again here, it is become 3 sin x. Now just multiply, you will get the answer. It will become x sin x by 3 minus 2 by 9. Derivative of sin x is cos x. This is our PI. Know how to find out the CF. So this is the linear differential equation with constant coefficients. All the questions I have done here is very important, and these type of questions is particularly asked in the B.Sc and B.tech exams. Do it carefully. Now practice it. In the next lecture we will discuss about the homogeneous equations with variable coefficients. I am especially जोर दे रहा हूँ इस बात पर. With the variable coefficients means till now we always get the constant here. Now in the further next lecture we will take the examples of these differential equations which have variable coefficient of x there. Till then practice it and bye.